I'd like to introduce now our next speaker. Where is he? Jay Yogeshwar. I like to call him on the stage. He is the Director of Media and Entertainment at Hitachi Data Systems, and he will talk about some of the challenges for the media industry, especially in the digital transformation for the production and content creation industry. So, welcome, Jay. Thank you.
Good morning. I'm really excited to be here, to be presenting in front of you, especially after such an amazing presentation from Jeff. So my name is Jay Yogeshwar. I'm with Hitachi Vantara, previously also known as Hitachi Data Systems. I'm responsible for the media entertainment vertical practice at Hitachi. And today I want to talk to you about how content intelligence and machine learning is transforming media workflows. So artificial intelligence, as we know, is the ability for machine learning techniques to mimic human behavior, human skills. But content intelligence, on the other hand, is another area that's kind of overlooked. Content intelligence is about taking advantage of the intelligence that's built into the data itself, such as metadata and analytics, in order to gain operational efficiencies. So first, I'd like to talk about digital transformation in media. A study by McKinsey recently said that digital transformation is affecting pretty much every field, but media is being disrupted more than any other sector, more than telecommunications, more than financial services, and so on. So it's really a confluence of multiple technologies, such as AI, machine learning, and Internet of Things that's disrupting media, and we'll talk a little bit about that. I'd like to share with you a short demo of AI. Normally, we think of AI as robotics, but really the techniques that is built into AI and machine learning is really applicable pretty universally through media. I'd like to share a number of use cases around video compression, around media asset management systems, and around OTT. And in order for machine learning to be universally applicable to media, we absolutely need the ability to have machine learning orchestration, meaning that we need to be able to apply all the algorithms of machine learning just as we do analytics today. So orchestration is important, and similarly for content intelligence, we need the underlying software infrastructures and systems to be able to exploit the metadata and to be able to exploit the analytics and the search engines underneath to create this master index to gain the kind of operational efficiencies and insights that we need. So I'd like to share my thoughts on that. But let's first examine what's happening with digital transformation at a very, very macroeconomic level. We know that our businesses, especially in media, are affected by the Internet of Things, analytics, and artificial intelligence. It's not just a phenomenon for the media industry, but it's a worldwide phenomenon. Many countries are actually incorporating a transformation as part of their economies. So what's happening? Consumers today want outcomes and not products. It's the millennials are a sharing economy, and systems are open. And so we want mass personalization and optimization. And this is really driving greater efficiencies and new business models across the board. But what specifically for what's happening in media? Over the last 5 years, we've seen a tremendous amount of disruption as a result of analytics technologies and cloud technologies. So what happened? As a result of analytics, we now understand extremely well what's happening with audience interaction with videos, for example, right? We're able to know exactly when a person is watching a piece of video, when that video failed, and did it stop, or how much did they play? So we know that, and that's helping us improve the quality of experience and the quality of service associated with delivering that piece of content. And cloud technology, similarly, is allowing us to deploy these applications at scale. But fast forward to today, and we're seeing new technologies such as machine learning and video analytics and content intelligence that is causing greater disruption. So it's really a confluence of all these technologies that's creating us to rethink our business models and see how can we gain more efficiencies, how can we monetize the content. And really, it's all building on one or the other. Video analytics and machine learning, for example, is a beast that needs to be fed with lots and lots of data. And that's why the cloud scale and the analytics techniques that we've perfected from before is really useful. And similarly, in order to extract metadata from video and apply that to governance and apply that to supply chain optimizations, we need the learnings from the cloud and the analytics. So all this has resulted, it's really a confluence of all these technologies that's helped us transform the media space. So let me share with you a short demo of AI research at Hitachi that is teaching a robot how to learn, how to swing. And this is based on what's called the H technology hypothesis. We're using the ability of the machine themselves to generate the hypotheses and not human beings. And the reason being that the machine can do only as well as the hypothesis that you give it. So what if the machine itself were to generate the hypothesis? So in this particular case, all we tell the robot, and this is, by the way, a Mindstorm Lego robot, and the algorithms are being run on a laptop. We want to outcome the swing amplitude. And of course, the only parameter that we control is the stand and sit timings. And we monitor the motors and the gyro. So here's what's happening. At first, it's making all kinds of random moves. But very quickly, it starts to get the hang of it. And within about a minute, it is becoming much better and almost is getting human ability to swing. And then at about, so this is about a minute, okay? And this is being run on a laptop, by the way. And after about 5 minutes, in fact, this robot is swinging far better than a human being. That's pretty amazing, right? And just so that, this is not just about teaching the robot how to swing, but also, hang from a bar and swing from a bar. So the same technique, there's no change in programming, the same exact algorithms or the artificial intelligence is applied here, and the same exact thing. After a while, it gets the hang of it, and then it's swinging better than a gymnast would. All right, so where does it fit with media? One of the most interesting use cases is video compression. We're today at our 4th generation of video compression, starting from MPEG-1, MPEG-2, MPEG-4. Now we are at HEVC. But I firmly believe that it's such a big optimization problem, and it involves human perception, that the next breakthrough is going to come from the ability to apply machine learning to the compression algorithms. I'm going to show you an example of what some companies have done in this area. The next big area is about nonlinear editing and media asset management systems. And here the idea is that our industry has to deploy many specialists who are golden eyes and golden ears, who have an understanding of what the stock footage looks like and where to get the content from. And that's a very laborious task, and we're paying a lot of people a lot of money to do that. So what if you had systems that would recommend content to you, as opposed to going and trying to find the right piece of content? And what if you're able to search large archives and come up with the right kind of spots that you need in order to create your program production? That could be a professional quality program production. Right? So it's a very interesting use case where we think we can apply. And how about over-the-top television streaming? I mean, that's a perfect example of where we've already used a lot of analytics and used a lot of the cloud technologies. But now it's really ready for further monetization, right? The difference between a OTT service that's pretty standard and blah versus the one that is making money for you, I think is going to be the one that determines who's going to survive in the space and who's not. So one of the areas is about coming up with the right kind of advertisement associated with the content. That's the primary monetization model for OTT. So now here, machine learning could recommend, it gives you semantic analysis of the scenes and could recommend, okay, these are the ads that is most appropriate. We call that contextual advertising. But we can take it a step further and create an ad mart where you could have real-time exchange between people that are placing the ads and people that are actually delivering the content. So all those are very interesting possibilities, and they're becoming very real, by the way. And the last example I want to talk to you is the e-commerce. Again, we're starting to see a lot of very interesting new startup companies working on trying to get additional revenues through interactive television, right? So make television just pop up. But again, you don't want the same type of interactivity one person with the other. And so interactivity could help people buy things, enable video commerce, and there are companies that are building the kind of platforms to be able to curate content and enable video e-commerce. So, machine learning and video analytics had its beginnings in public safety, right? That's where people could make money out of it. So for instance, you wanted to see, oh, where's the suspicious object? So very important for surveillance and video security. And also identify suspects based on faces and locate the suspect as to geolocation, et cetera. And then track their movements, and finally try to recognize, which car they're going in, license plate recognition. So now we are seeing a combination of all these things, but connecting the dots is important here, right? So it's not just about object recognition and license plate recognition, but now gaining situational awareness by knowing what is the meaning of a gunshot activity here or a license plate activity there. So wouldn't it be nice if you're able to then apply additional heuristics to be able to direct the police to the right place that you want to go? So smart cities and situational awareness are now very, very big, and directly as a result of video analytics to start with, but applying machine learning tools. So here's an example of what we could do with video analytics, which is count people and understand where the activities are. But more importantly, let's start to use additional elements and heuristics to improve business process and to optimize the business process, right? So we know how many people walked in and walked out, and what the interaction was with the counter or with the products that is in the mall, for example, and how many people purchased that. So now we're starting to see where it's not just about detecting objects, but also about making business processes more efficient. All right, so the next evolution in video analytics, right? So now if you start to apply deep learning techniques, we not only know that there is an object or there's a person, but we're able to detect the behavior of that person. We're able to find out attributes. For example, is that a male or a female, or does that person have short hair? What is the color of their clothing, et cetera? And now we're able to store all that information in databases, and we can get some very, very interesting inferences out of that. So here's an example of applying deep learning with what's called multi-perspective search. Okay, so we want to find a person in a video that has got short hair, and he's a male, and he's probably wearing a green jacket and carrying a briefcase. Right, so that's what we want to detect, and let's try to find all the cameras where we can find that person. And very quickly, we're starting to find those set of attributes, right, in the cameras. Again, this is this is sort of real-time deep learning example of applying multi-perspective search. Now we're starting to, it's now time that we borrow those techniques from surveillance and awareness to real media tasks. So how can we use that to mine the archives and get more advanced searches, right? So, and that's obvious. Media asset management systems it's an active area for them to incorporate these kinds of techniques to be able to get much more enriched metadata and to be able to then monetize their content. So, you know, companies like Deloitte and VizRT and Arvato are routinely using these techniques with the news production systems. That's a very straightforward use case because, you know, it's a well-posed problem. You have a person's face, and it's very easy to do that. But what happens when you have more complicated use cases? Okay, I want to find scenes where it's a kissing scene or a fight scene, right? Those are far more difficult. Now, going to the right, the degree of difficulty gets higher. So now, let's say you want to do product tagging, right? But you really do not know, you know, what Pharrell is wearing is what kind of hat is he wearing, you know, or is that even a hat that he's wearing, right? And then James Bond, he's got something in his hand, but you know, he's moving so fast, we don't know what he's wearing, or is that an extension of his clothing? So image segmentation to be able to tag products is definitely a more difficult task. And then, of course, when you have fast-moving scenes or grainy scenes, like sports video, for example, then to describe those becomes even harder. So we need better machine learning heuristics in order to be able to tap into those kinds of technologies and apply that for better nonlinear editing and better media asset management systems. So let's talk a little bit about the OTT and video commerce, right? So I personally work with several companies where they've had a need to create interactive videos and to tag the product in order to enable e-commerce over social media or through over-the-top streaming. So this is an example where one of our partners called Hollywoodland, locally based, that had a need to tag a product on a video and then go to the catalog of all the brands that are sponsoring and to be able to transact that product directly from the video through a pause and purchase type of activity. Now, in this case, we found, you know, just like any other sports activity, it's very, very difficult to segment it. So how about if we used assisted or supervised learning? So in this particular case, we had an actual person that segmented the football in the scene of the video and handed that to a machine learning tool that then identified all the different videos in which that product was there. Not only that, to be able to pick out the exact football from the Adidas catalog. Okay. So now we are starting to see real live uses for machine learning in media and commerce. So that's pretty interesting. Here's another example of a company that used the AI OCR recognition tool as part of the Google Tesseract library. And as you know, a lot of the bitmaps in DVB are very hard to code, especially if you're transcoding that. You take a lot of bits, right? But what if you were to use OCR technology and to capture that, and then to convert that to text, and then save the bits to code the video well? And that's exactly what they did at MediaHand. And this is a live service that's being offered within the Nordic countries. And they're using that to not only now offer you closed captioning in one language, but now you have, on the right-hand side, the ability to convert it to any different language that you wanted, right? So now, machine translation, OCR, is finding real live use cases in the media workspace. Okay, so now let's go back, let's take a step back a little bit. What does it take for us to be able to incorporate machine learning into a real software architecture, into a real system? On the right-hand side, you see, libraries that you may be familiar with, open source libraries such as Weka. Weka has over 160 algorithms that are built in. And then you have programming methodologies such as R and Python that are very, very good tools to incorporate machine learning into media. But the problem today is that these algorithms and tools are only the domain of data scientists, right? They're very, very specialized, but we need to democratize the whole process. We want people, business analysts, and people that have not so much knowledge of machine learning to be able to adopt that. Now, on the other hand, analytics is very, very advanced, and we know how to do data wrangling, we know how to clean data, we know how to categorize data, et cetera. But the two worlds today are separate, right? So the analytics world and the machine learning world are separate, and what's going to take is the ability to do machine learning orchestration to marry those two worlds. Today, they're exchanging data by means of a file, so the analytics processes will, clean up the data, categorize it, and give you a file. And that's a very clunky way to be able to fail fast and to apply machine learning to a media process. So we need to be able to fail fast. We need to have an agile methodology. And machine learning orchestration is the way by which we're going to bring these two worlds together, and that's absolutely necessary. So let's talk a little bit about content intelligence, right? Content intelligence, what I mean by content intelligence is the ability to connect various sources, whether that be structured, unstructured, any kind of data source. We want to be able to collect that and process that, right? And process that by different means, analytic means. We extract it, enrich, transform that. And the idea is also to incorporate machine learning algorithms within these processes and cache them and create what I would call a global index or a meta index or index of indexes, right? To make the search process very, very simple and straightforward. I mean, ultimately, machine learning is going to enrich your content with additional data and ideas to gain insight. So now we know what we're looking for, right? We're not searching different silos. We're searching the entire content repository, and we query that, and we gain insights. So content intelligence and machine-level orchestration is going to help take us from the edge to insight, and we don't all have to be data scientists to do that. So in conclusion, I'd like to say that AI and machine learning is not the domain of data scientists, that we're fast incorporating them into our day-to-day lives, into real-life machine use cases within media. And in order for that to be adopted much more universally, we need systems and software that can orchestrate machine learning and that can take the power of content intelligence, a power of analytics, and power of searching and indexing to make life much better for us in the media space. Thank you.
Thanks a lot, Jay. Please stay on stage for a moment. Bear with us. I also like to call back Jeff and Richard. So we have a couple of minutes for your questions now. You've heard a lot about the terms that AI is actually a marketing term. We've heard about the paperclip example that might take over the world, whatever. We've heard a lot about funny things. Thank you. A lot about funny things about gaming for machine learning, as well as the analytics, video analytics, basically. So I'd like to open up the stage for your questions. Please come forward. There's a mic in the middle. And if you just state your name and affiliation.
Sure. Phil Lelyveld, USC Entertainment Technology Center. So Jeff, one other thing AlphaGo Zero has done is it's learned how to play poker, and it won against 50 players not only by outbetting them, but learning how to bluff. For all of our use in AI, it's unreasonable to ask how the system came to an individual decision, but are we going to be able to understand the framework for decision making And with the AlphaGo Plus example, how do we know it's going to tell us the truth?
That's a great philosophical question. I feel a little on the spot on that one. Yeah, so the team over at DeepMind is just doing some phenomenal work on perception. There's some good interviews you can find online where the team responsible for AlphaGo Zero talks about gut and gut feeling. And when they interview, because again, there's 200 plus moves available to each, for each move within Go. And again, as I mentioned, the tree gets ridiculous quickly. And so you ask the player, how do you know you're winning? I mean, you don't, but you do. There's a confidence level. You've convinced yourself. There's a gut feeling that you're there. And so in allowing the system to play itself and learn, you're getting that same perception gut feeling. I mean, that's really what the system is doing. It can't run through all the possible permutations, so it's having to make a gut guess. And for me, that's where the DeepMind technology is so compelling with their work toward a general AI. Is they're really trying to capture what it is to be essentially human and have that gut, that intuition. And that's what those models are really embodying.
Ralph Fortolano from Dinuba High School Engineering. If there's a logic to biological evolution, what is to say that machines wouldn't follow the same patterns and be just as inefficient? It's taken millions and millions and millions of years for things to transform theoretically as they have, and there's billions and billions of opportunities for different directions in evolution. Why would a machine be any more efficient than the rest of the universe?
Well, because it's a machine and not a person. There's more, and if you think about like just, for instance, genetic differences, we're closer to petunias and fruit flies in genetic makeup than we are to the machines that we build now. I know they're not based on genes, but if you extrapolate that idea of, if you can change a gene and you could have a fruit fly with no head, right? But the genetic process doesn't allow that to happen, because you don't want those mutations to occur. But in a free environment where you're not constrained by survival, like a machine learning algorithm, or if you think towards like general AI, nothing constrains it like that. It doesn't matter if it breaks because you can just do it again. Its survival isn't dependent upon the outcomes of what it's learning to do. So it's unconstrained in that way. The way we are, like if we get it wrong, we die. If the machine gets it wrong, it just tries it again. So I think that's why AI has the potential to be more efficient, because it can go through those kind of evolutionary, if you like, steps without needing to worry about its survival, but also because it can just do it so much faster. So I think that learning explosion is something that will happen at some point. And, we're seeing people who are building deep learning engines going towards that moment where the engine can build a better AI than we can.
Then what's to say that AI isn't just part of evolution?
I think it is.
I love the philosophical questions. This is definitely good. Did you answer the sheep question from earlier?
Do they? I'm still on the fence about that.
Well, just to add to what Richard is saying, evolution is unsupervised learning. I would say, God is a supervisor, but he doesn't interfere too much. Whereas, we have a feedback loop possibly where we can say, okay, this is really working in our favor, and we should accelerate more towards that.
Yeah, I would agree on that. And really, like the examples I showed earlier, the only response was get the highest score you possibly could. That was the goal. It wasn't get a meal or anything in that regard. So the general AI is still fairly constrained in what the goals are. But again, if you're just feeding it pixels and you're producing this score, that you can extrapolate from there and see what happens. But I totally agree. Procrastination is not something that is being built into AI. It doesn't serve a purpose in that regard.
Hi, Janet Gardner from Perspective Media. Jeff, you talked about the opportunity to optimize or really change the way the entire media supply chain works through use of AI and various tools. And Jay, you talked about orchestration and the importance of integrating indexing and search also into machine learning and the metadata and other things we can extract. What do you think in 3 years our landscape could look like for media and entertainment were we to have tools that were evolved and built to support the capabilities that AI can deliver, and orchestration and search?
That's pretty great. Okay, I'll take a quick stab at that. So I try not to go beyond 2 years because I think everything beyond 24 months is magic at that point. But the team I'm working with to try and bring this to fruition, our goal is to be able to provide everything from automated clip cut up to, there's a sporting event, so you're able to generate a cut of the event from one team's perspective and a cut of the event from another team's perspective, and then individual player highlight reels. So we can do all of that today. The opportunity to be able to go through, however, and stream that to individual customers and provide targeted ads for them. I mean, that's a really effective way to monetize something. If you're producing an episodic show and you want to have a targeted ML-derived trailer for some other show that you want to be able to promote, that's also happening. More advanced recommendation engines and such. The opportunity to have just-in-time, real-time ML for an encoder that you're doing on a streaming service. I mean, these are all, very specific, go-to-market technologies that are either in development or have been developed by us or partners. So that's kind of where I see the short term. I see the kind of medium to long term, the capability of being able to decentralize the workforce and be able to not have to have massive, expensive, hot workstations under all desks, but instead be able to say, I have this crazy lightweight and I'll throw out a Chromebook in there, and be able to use a remote streaming protocol allows you to get at your data anywhere you want. And for me, that's incredibly freeing. If you want to hire a team somewhere, or if you yourself want to operate from kind of anywhere on the planet, when I fly on an airplane and have Wi-Fi available to me, I'm amazed at what I can accomplish over a pretty high latency link. It's exciting to me to see, just again, when I look at what any of our daily lives look like today, we really take it for granted in terms of, we have a complete, Unix supercomputer in our pocket, and it does incredible things, and it also makes phone calls too, which is really cool. But if you look at where we go in 2 years from now, from a media production standpoint, I'd love to see more ML applied for on-set capabilities to be able to tighten the production time frame on that. I'd really, like no one's turning off cameras these days, so we're just shooting a ridiculous amount of content. So the opportunity to go through and say, this is the start of a scene, this is the end of a scene, this was relevant. I want to have every take of Brad Pitt wearing Oliver Peoples glasses. It's less useful to do that at the end, after you've done all the production cut and such in your post-DI. Way more useful to be able to go back and look at the production data that was shot on set and say, yeah, we did 27 takes of this, ugh, it was expensive, but I want to take where the timing on the eyeglass removal is a little bit different. No problem, here's that take for you. So that's just enabling the editorial artist to be able to go through and be more efficient, and those are some of the advancements we're looking at.
Yeah, I mean, that particular one's really interesting. We've got a lot more like unscripted stuff at the moment, and the ability to, you might have 40 cameras shooting constantly on an unscripted, and you don't know what you've got. It's just not possible in the time frames that they need to work in to go through all that material. So you go for your hero stuff, but you might miss a gem that's come from like a little GoPro that was bolted to the underside of something. I don't know. But the point is that right now it's quite hard to do that without machine vision analytics. But I actually really like the mundane stuff. I mean, the boring processes that we can do better. Like we have a machine learning upscaler. So we've got like 5 upscalers, and they use different sort of simple methodologies. But the machine learning one looks at every little image patch and goes, this is the best methodology out of the 80 different ways I could make those pixels more pixels. And on that basis, makes very quickly a decision to do that across the whole picture. And that machine learning tool is not doing anything mathematically that the other upscalers don't do. It's just choosing in a very simple and quick way to do it very locally, and it's so much better. Like the image results of the upscaler are better. Think of all the stuff you've got in HD that you want in UHD, but you don't want it to look just like it's been upscaled, because what's the point? Well, machine learning is already allowing us to do that in a way better way that really is fine, because we've trained it with what that should look like when you upscale, and it goes away and does it. I mean, that sort of stuff is boring in one sense, but it opens up huge possibilities for the, you know, to just monetize archive, for instance. So yeah, I mean, I like that stuff.
Just very quickly, I think, you know, if you say today is the golden age for television, you haven't seen the golden age yet, because it's going to be, you know, user-generated content is going to be so much going to look like professional-generated content, because you're going to be able to curate such vast amounts of video using machine learning techniques. And you know, today is a sharing economy. We're willing to pay $10 for a latte, but we're not willing to pay $10 for a piece of content. You know, so we're going to have to look for new monetization models around content, and I think machine learning is going to enable us to come up with more ways to get paid for the content.
Okay, Pat Griffiths, Executive Vice President of SMPTE. A comment and then a question. To Rich's thesis about what do androids dream about, I'd say depending on who programmed them, they probably dream of other androids. On the question, though, mine's a philosophical question about the future of general AI. Great progress, I think it will continue, but I happen to be a big believer in the law of unintended consequences. To your point, Richard, if we build machines to kill us, they're going to do what they do well. I'm worried about, as we build more and more technology, general purpose in technology, could something go awry? I mean, your example of the paperclip one is a little far afield, but I'm more worried about the fact that we've created the perfect database for these AI systems, the internet. And so as they begin to access and get more of the knowledge about all of us, maybe this is a question more for Jeff. You know, what are your concerns about what happens when the machines are smarter than we are and we can't keep up with them anymore?
Well, I still think we're a little ways off on the singularity, but on a personal level, I expect we're going to get there. I don't have an idea of when, but I believe that'll happen. For me, it comes down to education and culture. The idea of having an educated populace that's well aligned morally, I think, is really important. I don't see, you know, massive amounts of government regulation being a really good idea in this venue. It's such an emerging field. It's hard to do that. So I would definitely move toward awareness and having people understand, you know, demystifying ML, which I think a really good job was done today on that, and making it more accessible, and realizing that you use it every day in your life as it is right now. I'm less worried about you know, the Skynet occurrence or the HAL 9000 occurrence happening. I like to think that the people who are involved in this across industries and across companies and fields and globally are aware that there are issues. You know, we have the Elon Musks and the Stephen Hawkings of the world and such saying, this is bad, be careful. I think when you distill out and abstract their comments, they're really saying, just be careful. You know, this is something that's important that we want to pay attention to. But we're still really in our infancy. This is just kind of baby steps as far as what we can do. We have a fair amount of compute. We have some interesting algorithms. We have some really talented women and men who are working with them, both, you know, in this room today and at a variety of companies. And I'm really encouraged by what I'm seeing. You know, I mean, who doesn't want more efficient cucumber sorting? But you know, moving forward, I want the most intelligent assistant I possibly can have. You know, I love the voice interface I have currently. I just want more of that. I want it closer to the visuals in Minority Report. I want, you know, I like the just-in-time lifestyle that I have, and I just want the AI to be even smarter that I work with. So again, I really see greater adoption. If you look back in time and you were to tell your parents, for instance, you're going to be carrying a telephone, and you're going to pay like $1,000 for this phone, and you're going to, it knows this information about you, and you're going to use it for these different things. And if you went back in time 10 years ago, they'd look at you like you were crazy, or even 15 years ago. Except we all have one, and it's my primary way of interacting with the world. So if we just look at the construct, you know, the delta between where we were 10 or 15 years ago and where we are today, and what that looks like, you know, all of my friends with 2-year-olds, they all know how to use an iPhone. Everything in their world is a voice interface or a touch interface. And it's not impacting them negatively. If anything, you know, when they can say, okay, Google Play Wheels on the Bus on the TV at 2 and on it comes, that's a good thing, but you also want to be able to turn that off. I really see us, though, as a society being able to move forward and be enabled by this, and I see it as a positive next step.
So Tom Coughlin, Coughlin Associates. So my question was with regard to, just a general advancement of technology. Right now we're doing a lot of the machine learning, the actual learning in data centers with large machines. What would be your projections? How many years it will take for the kind of capabilities we got now to be in things we carry with us, like our phones?
I'm going to let everyone else talk as well, so I don't own the mic.
Or bring it down closer
sure.
to the edge. Anyway.
I would say it's today, right now. The machine learning example, I didn't show an example of it, but you can download Google Translate and download a language pack for free, and the model runs on the phone. So I can be in People's Republic of Laos and hold it at a sign and actually get a visual representation of what that sign means in English or French or Italian or Croatian, whatever I want. That's available today. Tensorflow is open source. That's one of a variety of open source opportunities that exist. You can download and run that on really pretty basic hardware. You can also get access to unlimited cloud compute and crazy high performance for pennies. So that I really think we've democratized the compute capability, and by open sourcing it, made it available truly to everybody. And there's some really great online classes as well that you can take for free or very inexpensive dollars. So it really comes down to, it's all available today. It's how motivated you are to be able to solve the problem. And that's where I feel we're at. How about you guys?
Yeah, I mean, you can. The thing is, as I was saying at the start of my talk, the difficulty in some respects is the training. Once that's done, you can build very efficient networks that you can traverse really quickly. In the example that I gave of the 8,000 node 90 tree network, it's only 50 steps to get from the start of that network to the end. So you do that and that's why you can iterate it thousands of times in a fraction of a second. So, that is definitely what we have to do, because if everything we did, as was pointed out, I think, if everything we did went back to a cloud data center, then we're going to overload those data centers unnecessarily, because we're carrying that processing power in our pocket anyway.
Just one final thought on that is that I think there's going to be a lot of specialized ASIC chips, like Jeff mentioned. There's going to be chips that will specialize in combinatorial optimization that is very central to machine learning algorithms, and so that's going to reduce the hardware footprint considerably across the world. That's for sure.
Hi, going back a few questions, you guys were talking about how applying this machine learning to editing can help the editor a lot. Has there been any effort to apply the machine learning to live videography, for example, helping focus or helping steady cams or anything like that?
There's definitely ML work that's occurring, and if you buy a Pixel 2 handset, there's a stabilization capability with a huge amount of computer vision and ML on it. I was actually going to make a slide and talk about it. It's being utilized to be able to do single camera artificial depth of field, and they speak about the limitations of it and such, but there's also a stabilization function that's part of that. So I think we're there already. From a editorial standpoint, really just across the whole production pipeline, the team I'm working with internally has identified, we've just whiteboarded this crazy and multiple times, all of the possible areas we can think of, and we're also working under NDA with various customers to say, okay, what do you guys want? You have talented women and men on your teams, they're working really hard. How do we go through and actually make this more efficient and faster? The goal for us is to be able to reduce the amount of human time that it takes to be able to get something, reduce the amount of waiting that it takes. That's the most expensive and arduous part of it. In production, I learned how to juggle, and it's just why. It's fun, but I'd rather just get the picture back and be able to move forward from there.
I think that we might move away from traditional single lens type cameras and towards light field over time. The trick with light field is not so much the capture, because then you don't care about focus and all that kind of thing. And in fact, you can steady that picture afterwards as well. But the problem right now with light field is processing once you've got the data. And I think that's somewhere where machine learning can really accelerate our ability to use light field to capture scene and then do loads with it that we can't do right now with a single lens style capture. So I think that's going to come to bear probably in the next 2-3 years on that particular area.
I agree with you. I think the ability to capture multiple depths of field is going to be pretty straightforward, but using machine learning algorithms to figure out which makes sense, I think that's something that you will absolutely see in the coming years.
Thank you very much. Are there any more questions from the audience?
Completely exhausted the entirety of the AI knowledge base. That's it, like there are no more questions in AI.
I have one last question, actually, mainly to Jeff and Jay. If anybody of us in the room is about to start with machine learning, what do you think is the most important factor? Is it knowledge? Is that technology? Is it training material? What's for you the most essential part of it?
So yeah, training is absolutely the key. You know, we need to have very, very large data sets for training. And you know, choosing the right machine learning technique is also important to apply to the right problem. So in some cases, you know, unsupervised learning just does not make sense, right? So you do need to be able to have the feedback loop where you direct the machine learning algorithms in a certain direction to serve your purpose. So I think those two, the ability to have very large data sets from cloud, so cloud data sets, plus the choice of right algorithms is going to be key.
Okay.
Yeah, I would agree with that. The idea of being able to, well, first I'll give a shout out for the Coursera course on machine learning, as well as Tensorflow for Poets. There's a whole bunch of resources. Just do a search in order to get yourself to a point. But I really love the fact that I can have TensorFlow on my laptop and be able to run it discreetly. Most of the work that I'm doing is all supervised in the fact that I'm working mostly with visuals and images and such, and I have a known data set I'm working with, and I want to be able to get you know, specific advancements in image recognition for various objects and such, and I'm working, you know, with well, temporal awareness as well. So those are the things I'm working with personally. I don't have access to the DeepMind general AI at this point, sadly, but when that becomes available, I really look forward to working with it.
Okay, great, thank you. We have 2 questions and 2 minutes left, so if you can make it very short, please.
Okay, Keith Graham, consultant. One quick one, picking up on Pat's comment. I hope that everybody who is developing AI and ML has Asimov's rules of robotics written up on the wall in very large red letters. And the other question is about hacking. I mean, we all saw the video a little while back of the people who hacked into the Jeep Cherokee and drove it into the ditch. What's the risk of somebody maliciously getting into an AI or an ML program and actually giving it wrong information and getting the wrong answers?
Yeah, that actually happened to us last week. We had someone hack our upscaler and it killed about half our workforce. So, I mean, it was a terrible upscaling death tragedy. That,
The horror.
yeah, horror. They were all upscaled to death. I mean, I think the same risks of cybersecurity exists in that field as everywhere. I think we have a general cybersecurity risk that is pretty substantial right now. I think what you should be more worried about is hackers using ML to help them hack. That's scary.
Yes, the automated bot attack net. Yeah, that's, you know, at Google we have, you know, hundreds of PhD researchers and thousands of security personnel. We like to think that our cloud and private global network is more secure than on-prem, and we can talk about that at length another time. But the idea of general cybersecurity, completely agree. It doesn't really matter at the end of the day what happens afterward. It is just keep your system secure and follow best practices to do that.
Okay.
Hi, Ben Wagoner, Amazon. There was a brief tease that flew by about machine learning for optimizing video compression. I wonder if you could say a little bit more about that.
Thanks for catching that. Please jump in, go.
Sure. You know, in MPEG-4, there was this concept of video segmentation to be able to identify areas and apply the right type of compression to, you know, whether it's an edge or you know, whether it's an object that someone would follow or not. So essentially, there are hundreds of parameters that you can optimize to compress video. So there's human visual perception techniques, there's quantizers, there's motion estimation, motion detection. And today, if you look at the compression people that optimize that, it's all based on heuristics and people's knowledge about how compression works. But it's just humanly impossible to tune all the different parameters that go into getting the best possible picture quality. So definitely it's a very, very important area where we think that machine learning tools will absolutely help you to optimize quality. So video segmentation, image segmentation, and applying psychovisual techniques to the segmented images, but also just routine tasks of picking the right quantizer size to be able to optimize quality for a given bitrate or bandwidth is going to help.
Okay, thank you very much. And by that, I'd like to thank our speakers, Jeff, Richard, and Jay, for their insights this morning. I think we've learned a lot. Thank you very much.